Ava is flying a drone in a large open space at a constant height of 5 meters above the ground. She flies the drone due north so that it passes directly over her head, and then sometime later reverses its direction and flies the drone due south so it passes directly over her again. With t equals 0 defined as the moment when the drone first flies directly above Ava's head, the velocity of the drone at time t seconds is given by v is 2 sine t over 3 plus pi by 6 meters per second, and this works for t between 0 and 16. We want to determine x of t, the displacement of the drone at t seconds, where x of 0 is 0. And so if we have Ava here, the t equals 0 is here, and then she's going to fly it off in that direction, and then she's going to fly it back this way, and so on. So we want x, and we get that by integrating v. So sine integrates to negative cos, so we'll have negative 2 cos, the argument won't change, t over 3 plus pi by 6, but we need to divide by the differential of the inside function. If we differentiate the inside here, that is just 1/3. Dividing by a third is the same as multiplying by 3, so we get negative 6 cos t on 3 plus pi by 6 plus some constant. But we know this information here. So 0 is going to be negative 6 cos, t is 0, we got pi by 6 plus c. So that will give me that c is equal to 6 times cos of pi by 6 is root 3 on 2. So c is equal to 3 root 3. And that gives me then that x is equal to 3 root 3 take away 6 cos t on 3 plus pi by 6. Okay, let's move on to part B. Where is the drone in relation to the pilot after 16 seconds? Well, that is just going to be x of 16, which is 3 root 3, take away 6 cos 16 on 3 plus pi by 6. Calculating that gives us x is equal to negative 0.267, and since we had north as being positive, that would make it 0.267 meters south of Ava. Okay. At a particular time, the drone is heading due south, and it is decelerating at 0.5 meters per second squared. How far has the drone traveled from its initial position directly above Ava's head until this particular time? So if we had Ava here, we know the thing is traveling in this direction. The velocity is negative. So we can differentiate to get acceleration. So we're differentiating the initial velocity formula that we were given up here. And if we differentiate that, remember to use the chain rule, we are going to get 2 cos t on 3 plus pi by 6. Using the chain rule, we're multiplying by a third. And so that is going to be 2/3 cos t on 3 plus pi by 6. Now, decelerating at 0.5 means negative 0.5 equals 2/3 cos t on 3 plus pi by 6. And we want to solve that. And don't forget, on the class pad, use the given line with t between 0 and 16. Make sure you're in radian mode, and that will really help. And you'll get t is equal to 5.6858, and 10.0222 as the answers in the given range. If you then go and take that and put it in the velocity, you'll find that the v is positive at that time. And we know that the v is negative. So it's this one we want, with the v being negative. And so for distance, remember the trick with the integral of the modulus of the velocity, we are going to do the integral from 0 to 10.0222 of the modulus of v of t dt. So in there goes your expression for v, the one from up here. Stick that in there in the modulus signs, and you will get 12.696 meters. I think that's right. Yep, I've just been and checked it. That is correct. Couldn't read my own handwriting there for a moment. And so that is the final answer.